breakthrough area is memory, which also very important. Two, disruptive technologies to accelerate your innovation. The first one is 3D NAND and 3D XPoint technologies. Today, we have 3Ds for your choice based on your cost and performance considerations: HDD, DRAM, and NAND. And actually, by using 3D NAND and 3D XPoint, we will be able to fundamentally change the area. Here, I'd like to invite Intel's Senior Vice President, Mr. Rob Crook, to give you a detailed technology demo.
Hello, Rob. Welcome to IDF. Yes. And can you please introduce our latest memory technologies to our IDF audience? The floor is yours.
Ian. Well, Ian, thank you. It's great to be here at IDF. I'm excited to talk to you about our amazing advancements in 3D NAND technology and 3D XPoint technology.
Yes, please.
And we thought we would start with our 3D NAND technology, which focuses on both cost and capacity improvements, and take a look inside the technology to see how those memory cells are actually constructed. Now, we use a floating gate memory technology in which we trap electrons to store bits of information. Our first design is arranged in 3 dimensions so that we have a cube of memory cells. And if you look down on that die vertically, you'll see 4 billion pillars. And each pillar consists of 32 layers. And at each intersection, there is a memory cell that stores 3 bits of information. That gives you 384 billion bits of information stored on one die. Now, because we've moved to 3 dimensions, we can get to higher densities and continue to scale more efficiently by either stacking more layers vertically or by moving pillars closer together, or by storing more bits in a single memory cell. This gives us a breakthrough in cost and capacity advantages. And by next year, we'll be able to store over a terabyte of information in 1.5 millimeters. That's 1.5 millimeters thick. And this will be great for notebook products. And in a traditional SSD form factor, we'll be able to store up to 15 terabytes of information. And then in a rack for the servers, we'll be able to store up to a petabyte of information in 1U in a 19-inch rack. Now, I'd like to talk about a completely new type of non-volatile technology that is a breakthrough in speed and performance. I'm talking about 3D XPoint technology. 3D XPoint technology is up to 1,000 times faster and 1,000 times more durable than NAND, while delivering up to 10 times higher density than DRAM. But unlike DRAM, 3D XPoint is non-volatile, so the data remains intact, even when the device loses power. Now let's take a closer look inside 3D XPoint. Now, although 3D XPoint sounds similar to 3D NAND, they both start with 3D, it's fundamentally different in the physics of how it operates. It has no transistors and is much, much faster. You can access a small byte of information instead of large blocks of information like 3D NAND. And to achieve this high performance and high density, we start by slicing layers of materials into columns. And each column contains a memory cell and a selector. Then we connect these columns using an innovative cross-point structure of perpendicular wires. This enables us to address individual memory cells by selecting one wire on top and one wire on bottom. Each cell can store a bit of data. Now we can stack these grids on top of one another 3-dimensionally to increase density for larger memory capacity. Now, these memory cells can be written to or read from by varying the amount of voltage sent to each selector. This enables us to eliminate the need for transistors, which increases our capacity and reduces cost. Meanwhile, the use of these unique fast-switching materials result in fast access, up to 1,000 times shorter delay than NAND. That makes 3D XPoint usable as system memory, as well as great for high-performance storage. Any application that requires large memory capacity or very fast storage will be able to leverage this technology. Now, this is really exciting for big data tasks like pattern recognition, deep learning, or genome sequencing. They'll all benefit from this technology. The possibilities are truly tremendous for these type of vertical markets, as well as areas that you all will discover. 3D XPoint is the biggest single advancement in memory in over 20 years. And it will be exciting to see what you, as the developers, can do with this amazing technology. Now, I'd like to welcome Ian back out, and maybe we could show you a little bit about the technology.
Rob, that was really impressive. But do
you.
you have something like in action you can actually show to our audience?
Yes, Ian. Actually, I happen to have a demo over here.
Perfect.
That showcases 3D XPoint technology, and we offer this under the Optane SSD brand. So what do we have over here is two identical PCs. One has NAND-based solid-state drive on it on the left, both inside the PC as well as connected through a high-performance Thunderbolt 3 connection to an external drive. And then on the right, we have a 3D XPoint SSD, Optane SSD inside the PC, but then another one outside the SSD connected via Thunderbolt technology. Now, what we're going to do here is the only difference in those systems is NAND on one side and 3D XPoint on the other. Now, David here is an aspiring home video editor, and he's just finished a masterpiece that he'd like to make sure he gets backed up so that he doesn't lose this information. Now, normally, this is a large file, so about 25 gigabytes of data, and it would take a long time, about a minute to copy that. With Optane, it will take just about 15 seconds. And you can see the speed here is much, much faster. You can see the speed's about 2 gigabytes per second on this early sample of an Optane prototype SSD. Now, with the growing size of data today, we can see dramatic reductions in file transfer times, loading times. This technology will be essential for any time-critical application.
That is really fantastic. And this is really going to revolutionize the whole memory industry. So thank you, Rob.
Thank you,
Appreciate
Ian.
it. Thank you.
Have a great day.
Yep. Thank you, Dave. Thank you.